Spark is where most people wash out of their data engineering interviews. And today I'm going to give you a blueprint so that you could walk into your next interview and say, I took a 28-minute job down to 11 minutes. It was the same cluster, but a better plan. And I'm going to give you a cheat sheet that you can start using today. If a few table keys end up hogging your compute and one partition is running forever, that's data skew. Data skew eats budget and stalls your whole pipeline. Adaptive query execution, or AQE, changes the plan while the job runs. Turn it on and check if it splits the skew. Here is how you do that. Enable adaptive execution. Spark can change the plan on the fly to avoid any bad choices that may be in your code. Next, turn on skew split so that Spark can cut a whale partition into smaller chunks. That's what we're doing right here. Let Spark merge tiny shuffle partitions so we don't waste tasks on breadcrumbs. And that's this coalesce partitions piece. And then finally, local shuffle reader reduces cross-node traffic. Less network, more speed. Your next surgical cut should be salting. Salting is a skew mitigation technique where you add a small bucket number to a hotkey so its rows get split across multiple partitions. After the wide operation, you remove the bucket and combine partial results. It keeps your work balanced without having to change the logical key. There are two concrete patterns here. Salting for aggregations is the first one we're going to talk about. The goal here, stop one key from owning one giant partition during a group by. The steps: 1. Add a salt bucket column for your hotkey. 2. Do your group by on the salted key, and then remove the salted by re-aggregating on that original key. It looks something like this. We're going to start by importing our functions, and then we're going to assign our buckets. Start small. 8 buckets here ends up keeping the overhead in check. We're going to add our salt column and a random bucket to the hotkey. That hotkey now fans out across our 8 partitions. Aggregate by the salted key, and that way each bucket computes a partial sum. No single partition ends up taking all the pain. Remove that salt, split the key back into the real customer ID, then re-aggregate your partials to the true total. Now, some quick guardrails. Cast the pieces to string before your concatenate functions here. If types end up being mixed, and validate totals after unsalting. All right, here's your second pattern. Salting on joins. Your goal here is to stop a skewed key from forcing this huge shuffle in a super large join. So here are your steps. You're going to add a bucket on your big fact table on the skewed key. Then you're going to duplicate the matching rows on the small side into the same n number brackets. Finally, you're going to join on both the key and the bucket. And then after all that happens, you're going to drop that bucket after your join has completed. The code looks something like this. All right, we're going to start by creating our bucket, our n, and in this case, we're going to use 8 again. And then we're going to, again, just assign that random bucket. That way, we're spreading that out over our n partitions. Then we're going to duplicate the matching rows on the small dimension into all those n bucket. That gives every fact bucket a partner. Then you're going to join on both the real key and the bucket. That way work evens out and you don't have some whale of a partition that's really sucking up all of your compute. Then you're going to drop the bucket because we don't need it anymore. The result ends up being logically the same, just computed without any straggler. Now, start with 4 to 16 buckets when you're doing this. If tasks still end up lopsided, bump it. If you get dozens of tiny files, bring it back down. Use salting when a few keys ends up dragging your whole job down and the AQE doesn't end up splitting things evenly. Remember that joining salting multiplies the small side by whatever your n is. So be sure you're watching out for out-of-memory errors. When to use salting? You see long straggler tasks tied to some small set of keys. You need to jump in on some salting. AQE skew split is off, unavailable, or maybe it's not effective enough. You need a deterministic fix you control in the code. Remember, salting splits a hotkey into a few buckets so that you can balance your work. Then we're merging the partials back into the real key. AQE adapts at runtime. It switches joins, splits skew, and shrinks tiny partitions to optimize your runs. To really understand salting, you need to understand Spark's most expensive thing that it does, shuffling, which I explained to you in this next video right now.